Hi, welcome to my session on how to test a project in data science written in Python. Okay, so today there are a couple of things I'd like to go through. Number one is the context of application testing from the development point of view and from the external party point of view, namely the auditing point of view. Second, I'd like to talk about the ecosystem of Python, what Python can offer in terms of testing. Number three is to go through the three phases of testing: unit testing, acceptance testing, and integration testing, and look at, from the two contexts, and look at the ecosystem that Python was offering for these three phases. And lastly is to go through a short demonstration to show you how I tested Python throughout those three phases. Okay, the two contexts. We as Pythonista and mainly from development point of view, we know very well why we want to test. And I point out to you the two books that I enjoy a lot. One is the Hitchhiker Guide, and the other one is the Test-Driven Development with Python. And mainly we talk about testing as the tool for us to really to prove to ourselves as well as to our shareholder, our stakeholders, how good, how beautiful is our code. Here you can recognize the testing goat that is basically the symbol of the TDD test-driven development, and I picked it up from the book from Percival, excellent book on testing, and also I must read book on Django. So from the development point of view, let's look at the other side and look at how the external party look at this. And on the extreme side, external party, we can talk about our boss, our client, who basically have an idea of what we are doing, but most of them won't have a clue how our code was, what our code was doing. And on the very extreme side, if you are lucky enough to work in an industry where it's heavily regulated, then very likely your code would be subject to auditing. And from the auditing point of view, the testing is of interest because it has to do with change. And you can see here the code I got from Isaaca. Isaaca is an organization on IT auditing, and they have a framework which is now called COVID version 5. And this is the section that I pick up on change, which is what they call AI6 managed change. And you can see here the emphasis on control of how change was managed, how we as IT respond to the requirements, how that align with business strategy, how that reduce solution and service delivery defects and rework, and mainly here the three key deliverables that auditors like to look at. Number one is whether the change were defined and communicated. Number two is whether there are evidences of the change which is being assessed, prioritized, and authorized. And number three is the status of the change and the report on change. These three are the key artifacts or evidences that auditors would like to see whenever there are changes. So the main question here for me to try to answer is, can Python, on the one hand, satisfy our needs as a developer, and on the other hand, can help us developers to provide the artifacts and the evidences that auditors require. Let's see. So the other perspective or context, for application testing is when we do data science. Data science by itself has many challenges, and the answer for that is for us to use the CI/CD, the continuous integration and continuous delivery. And from the CI/CD perspective, I have highlighted here the key component, integration, delivery, and deployment. And within integration, you have build, test, and merge. Delivery is the auto release to the code repository, and deployment is auto deployment to production. And I have put in here a couple of facts related to each of them. And you can see here is again the context or the focus for us as a data scientist. We want again to see how robust is our code, how we can repeat the environment that we from which we produce our code, the environment and the data and the algorithms, and how our development has become something that is useful to our organization, i.e., a monetized service or some useful insight, etc., etc. From the auditing and compliance point of view, they are looking from the external angle, and they want to know whether what we are doing, what we are deploying to production, where those changes, where they coming from a authorized business request, which mainly should be captured most of the time, or would be captured in a use case, whether the data we use have been so-called vetted, whether there is some kind of, whether we know the source of data, whether that data has been vetted, whether the algorithm that we use, whether that has been tested somewhere, verified somehow, etc., etc. So that's again the two opposite point of view. So let's go and look at Python from that CI/CD perspective, and see what are the tools that are available for us. And when we talk about tools, the term that I like to see is in fact is an ecosystem. Basically they are intertwined and interlinked. And as you can see from my picture down here, all those tools somehow is very hard really to put them into one or two slots. Basically, some of them span across the continuum. So and those and there are many more than that. That's why I put it in. Making sure that we know that these are just but a selection of tools. And out of this selection of tools in this study, I only touch some of them. And those that I touch are the one that I put in here a tick mark. And the other one, I had the intention to do that, but then time was running out, and so be it. So basically, it's something that I put in as an agenda for me, for myself, to further investigate. So let's go and look at a couple of key points. So number one, let's talk about the code analysis, which is really starting point of our testing. The question is, how well do we know our code? Obviously, in order to test it well, we need to know it. And a way to do it is interestingly enough, is through PEP8. So PEP8 by itself is but a guidelines. This is actually not but the guidelines. This is Bible for us on how to write Python well. It turned out that a lot of tools were based on that PEP8, and the byproduct of those tools is that they can provide reports and help us for us to not only to write better, but actually to understand our code better. And in here, you can read it through. You can see here the two tools that I selected to look at, Pylon and Radon. Pylon by itself is very close to PEP8. So it's a linter. So the linter is to look at making sure that we follow the guidelines, and it does help us to make our code more readable and more maintainable. But then from the auditing point of view, the bonus from those tools is actually provide artifacts on our code. And you can see here it is an evidence that we are following the best practice, i.e. This is a proxy of good governance. And you may notice that it is although it's a good indicator, meaning that from auditors they don't really require this. So this is mainly for us to provide to have something to help us with our development, and to show to people from the outside that we are doing a good job, but they are not really kind of requirements when it comes to auditing. And you can see here later on during the demonstration that I have put in some of the artifacts that I get from these tools here in these two appendices 01 and 02. So unit testing. So unit testing is basically again something for us, for developers, and we want to know, one is there are any errors, any exceptions, whether the code went through okay or not, and also we want to know whether the that kind of analysis covered the entire application, mainly the code coverage of the testing. from the auditing point of view, again, this is not a requirement, but again, it's a bonus. It's basically because these tools, and I use here PyTest and PyTest coverage. These tools here provide out of the box a lot of artifacts that auditors can use and help them understand, the code, the application, without having to go and ask us for details. And that is, a win-win, for us as developers, not to have to spend time to explain to auditors. And on the other hand, the auditors also can go directly to the tool, retrieve the artifacts without, having to come to us and ask for details. Acceptance testing. This is actually something that is required from the auditing point of view. Remember that, when we talk about COVID, and the requirement is, the changes in production have to be authorized. This is the evidence, the artifacts that tell auditors that the changes that we are making in production are deriving from a request or a business need, and this by showing this user acceptance, we can basically show first, the business request, and then because we pass the test, then obviously the users have accepted the change. And the tool I use here is PyTest BDD. BDD is behavior development driven, and there are many other tools. I just happen to use PyTest BDD because it's part of PyTest ecosystem, and the evidence of this is in Appendix A05. Okay, so integration testing. Okay, this one is also something that auditors, love to see. This is where basically, our changes, the code that we made, directly went to production and make change into production, and they like to see, when the change was made, who made that change, and this is what they call the question of segregation duties. Ideally, it's expected that the developers, those who write the code, would not have access to production and make direct change to production. In the CI/CD case, the change that we made, the developers made, went through a automated deployment, a machine-like, and the machine can be considered as a third party, given that the automation can be demonstrated by looking at the logic of deployment and looking at the evidence of deployment. And the tools that I try to use here is Jenkins. And you may notice that actually Jenkins, we are using already another tool called Travis. And the difference between Travis and Jenkins is that Jenkins can be Travis is a web-based resource, and Jenkins can be configured locally within the organization server. And for many of the big shops, that is an advantage, that basically they can control the code internally without seeing their code being made available in on the internet or outside of the control. Okay, so we are going through demonstration, but a final thought is, definitely Python, as we have a look now, is basically can be for anything. But one of the main interests for us data scientists is how we are going to test machine learning. And this is again a topic that I propose to myself to look at. And a couple of things here, challenges particular to machine learning that I put in here, and the reading that I base upon, that I come up with over here. Okay, so before we start the Q&A session, let's go through the rest of the material that I have. Here are the references, and here is the documentation of the tools that I found. Here are the books that I read, to basically to help me to understand the topic. And now is the demonstration. So first of all, I have put all my code in my in this GitHub, which is not the standard Harvard repository. This is my private GitHub because remember that the way that we configured is when we deploy to GitHub, we trigger Jenkins, we trigger Travis, and in this exercise, I chose to do Jenkins. That's one reason. Another one is, I play around a little bit with the configuration, so I don't want to mess with the repository we have in at Harvard. So here's the main page of my GitHub with README, PSET4 file. A lot of these things that I propose in here, I did not have the time to do this time for this exercise, and this is something that I may come back and have a closer look. Over here is the repository, and you can recognize the structure of the PSET4, except for, say, we have here Eurostyle, source, PSET4, and utils. And here is my testing folders. You can see here that we have I have a test PSET4, which is the standard PyTest file. And then here the features and the test steps, which are the two extra folders I had for PyTest BDD. We have a look at it in a couple of minutes. Okay, so code analysis. So I use two tools. One of them is Pilot, and in here, sorry. So in here you can see the result that I extracted directly out from the report, and you can see how it actually was reading my code, and it says there are a couple of things it flagged. Obviously it didn't like my code, but anyway, you can see the kind of details, and it could be good to look at it and go back and try to fix some of these here are cosmetic, I believe, but some of them actually point out to things that things that I propose to write a routine, a method that I was planning to write, and then I chop it out. Maybe I come up with a better method, or maybe I forgot to complete the method. This one is the class diagram that Thailand can generate. It's free, so it's very fast. It's not very readable. I think that the one that I get from PyCharm is almost or maybe better. But this is very good. This is very impressive. At least give me an idea of the structure diagram, and you can see here is I try to draw the class diagram of PyTorch, which is a little bit complex. So I just show here a portion. Okay, and the second tool that I use that I also like is Raiden. So Raiden offered a couple of reports, and what I produce here three of them. The number one is the CC, which stands for cyclomatic complexity, and it can basically provide you the score. It can tell you whether what kind of how complex it is, whether it's a simple block or is it a moderately complex block, and so on and so forth. And in here, it can even give you details whether this is a function, a method, or a class. And you can see here the scoring and the basically the classification. Again, this is out of the box and very fast, very quick. The second one is the Raiden row report, and it could give you here an idea of per module, and it can give you here the line of code, the logical line of code, the S-log, so etc. etc. And in here is the MI report, the maintainability index, and it's actually I think this one is a little bit too forgiving, because from 100 to 20 is very hard. So it's very pleasing for myself to see that all my tools are highly maintained. Okay, so what I did for testing is actually you know that we had to come up with a test PI code, and because I chose PSET4, what I have to test also is, on top of that, I need to test Luigi. I need to test AWS, and in here in this part again I show you the overall structure of my test, and basically all the import and all the key classes that I developed for PSET4, and which is where I put it in the code here to test each of them. I have used a lot of code from Luigi themselves. Luigi provide a suite of not a suite, but a series of tests of their task, and I have looked at and used it to test my PSET4 code. And you can see here the setup for a standard setup for one of the class. You can see here the unit test approach, starting with setup, and then a tear down where we basically after we close out the test, this is the part where we wrap up and clean up before we leave. And in here is the typical component of a Luigi task. This is the simulation of output. I will use a mock target, which is coming from Luigi. I also use a mock S3 as well, because in PSET4 we need to get access to AWS. And in here is the specific test that for this image content image, this is the part where we go and fetch the image that is stored in AWS. So here is a test read, and you can see here this is the convention of unit test. That in order for unit test to understand that this is that it has to test this, it has to the method has to start with the keyword test. So here is to test the read with the file. This is the test the read without any file, without any image in there. This is the iteration where we test, and there are 1 or 2 files in there. Oops, sorry. And then here is the test of whether the path has been read correctly or not. So this is very detailed, test steps that we basically that I have to develop to make sure that this class of mine actually could perform all the steps that I expect from it. Okay, so here is the result. So you can see here that I use PyTest to produce results, and the result is in HTML format. So basically it's very nice looking. It has, this is the part that auditors know. One is to it can have the evidence of when the report was generated, the environment, a summary of the test. There are a couple of sections here: the error section, the failure section, and the section where the test has passed. And here is a zoom in to one section of the error, would tell me where it found errors and so on and so forth. Oops. Okay. Appendix 5, acceptance test. This is the result from PyTest BDD I mentioned before. So this is the screenshot of my pie chart, and in here is the features. Basically, this is the English-like description of the functionality, and out from here, PyCharm could generate part of it. Actually, it only generates the then statement here. All these given and features statement here were handwritten by me. The entire code here doesn't run yet because I basically I didn't have the time to thoroughly test this PyTest BDD, but it does give me and hopefully some of you an idea of how this can be used for as an evidence that our code actually was addressing our client request or needs. Here you can see here the folders that I created in accordance with PyTest BDD that you expect two folders, one for the features itself and the other is for the testers. Okay, so here is the phase where I want to see an alternative to Travis Jenkins, and I again with most of the tools, Jenkins is almost as popular as Travis. There are things that are very nice, and there are things that I guess that I need more time to investigate. So here's the configuration of my project. I told Jenkins to expect to use Git as the versioning tool and to use GitHub as the repository of, of this project. Here is the script or the integration logic. What can be done? You look closely at it and you will see that it's not using PyTest but Nose. And the trend now, as you know, is we go for PyTest instead of Nose. So that's one thing that I don't really like. I didn't have the time to test how Jenkins behave with PyTest. The other part is also you can see that I use pip instead of pipenv, and I have to manually create a virtual environment. Again, I try pipenv, something that maybe it's not standard with Jenkins, so it's not straightforward. So that's something that I don't really like. But of course, I didn't spend enough time to really declare whether Jenkins is a good tool or not. Obviously, like I mentioned, Jenkins is very popular, almost as popular as Travis or maybe more. And here is the part where what kind of reports we want Jenkins to produce once it run the job for us. Here's the results. So here you can see your dashboard. So you can see here the project that has been run. Obviously it ended with errors here. So it's a red flag here. This is the repository where actually it cloned from GitHub, put it in here and use it here to redeploy to GitHub once I make the change. Here's the results in details, the dashboard results. Here are the details of the run, what kind of problems it found, and here is the report from Nose, similar to PyTest. Also explaining, here for some reason complained I couldn't find Botu, although I put it in here, but then obviously Botu was declared in pip file, and I guess that Jenkins doesn't read pip file the way that Travis read pip file from pipenv. Okay, so before we go to Q&A session, a big hooray for all of us. We made it. We made the finish line, and good luck to every one of you. And we shall meet again very soon. Thank you.